All right, my students and friends, what's happening? Now, today we're on 5.2 notes, and this is factoring. Now, so far we've been examining parabolas, and we've been focused on part of our graph was our x-intercepts. Now, those are the solutions to the graphs. Those are the pieces that are very, very, very important. So what we do is we have many other methods to solve for that algebraically. All right, now over the next 2 days we're going to talk about 4 different methods. On the video tonight I'm going to share 3. All right, the first method is GCF. Now GCF stands for greatest common factor. All right, now when factoring out a GCF, right, the main goal is to find what's in common. So for instance, let's say we had 6x squared minus 2x. All right, and I said factor out a GCF. Well, 6 and 2 share what? Well, the largest number that can come out of them both is 2. And then here I have 2 x's, x times x, and here I have 1. So they share 1x. So then left on the inside of the parentheses, we would divide it out. 6x squared divided by 2x gives me 3x. Negative 2x divided by 2x would be minus 1. I've now put it in factored form. Now you can always check your answer by, if you were to distribute this back out, it should equal what you started with. Alright, now let's look at a different type of GCF. We have 5x squared y to the 10th z minus 10x to the 12th y plus 2x squared y to the 5th z squared. Alright, so the first thing we're going to take a look at is the actual numbers. So I have 5, 10, and 2. What do they all share? Well, 5 and 10 share 5. However, 2 doesn't work because 5 is an odd number here. So actually the numbers share nothing. All right, we cannot factor a GCF out. You can put a 1 to hold the place value if you wish. All right, now we're looking at 2x's, 12x's, and 2x's. All right, how many x's can I take out of each? Well, if this one has 2, this one has 12, this one has 12, we only share 2 x's amongst them all. All right, so we can take 2 x's. Let me move this down a little. So 1x squared. Now let's take a look at our y's. We have 10y's, 1y, 5y's. So we can take 1y. And then looking at our z's, we have 1z, no z's, 2z's. Alright. So then let's start our parentheses. Now 5 divided by 1 gives me 5. I had 2 x's. I took 2 away. I'm left with none. I had 10 y's, I took 1 away. I'm left with 9. I had 1 z, took no z's, so I'm left with z. Negative 10 divided by 1 is minus 10. Had 12 x's, took 2. I'm left with 10. Had 1 y, took 1 y, no y's, no z's. 2 divided by 2, 1 is 2. Sorry. Had 2 x's, took 2 x's away, so I'm left with none. Had 5 y's, took 1 away. I'm left with 4. Z, no z's, so I need 2. Again, if I were to multiply it back out, I would get the same answer. Alright, so that's GCF. The second one I want to talk about is a difference of 2 squares. Again, please make sure we're taking notes and we're not just listening to me talk. These are important notes to have referenced when we're working in class tomorrow. So difference of 2 squares. Now this one kind of has to meet some requirements in order to be true. So one, it has to be a difference. So a subtraction problem. Okay, the 2 refers to it needs to be a binomial, which means it has to have only 2 terms. And the last thing is you need to have perfect squares. Right, you need to have perfect squares. So for instance, x squared minus 4. Now, one way I like to think about factoring is reverse FOIL. All right, so we want to write this as if this was a solution to my FOIL problem. Now, it is a subtraction problem. It is a binomial. It only has two terms. And x squared and 4 are both perfect squares because the square root of x squared is x because it's x times itself. Kind of like the square root of 4 is 2 times itself. That's supposed to be 2 squared. Alright, so x squared is a perfect square. Now, what you do is the square root of x squared is x, the square root of 4 is 2. And then we make 1 plus 1 minus. That's kind of the shortcut. Now, it's important that 1's plus 1 minus, because look what happens when you FOIL this back out. I get x squared minus 2x plus 2x minus 4. And due to the fact that's a plus and that's a minus, these middle terms are always going to cancel out. And this last one's always going to be a subtraction problem. Alright, so this is the answer I'm looking for. This is an explanation why. Okay, why it works. So, let's try another one. Let's go 36x squared minus 25. So again, the square root of 36x squared would be 6x. The square root of 25 would be 5. 6x and 5. 1 plus, 1 minus. Please FOIL out to double check. Alright, now the last of the third one is what I like to refer to as old school factoring. Alright, now old school or regular factoring is when we have it in standard form, right, and our a value is always positive 1. So these are the ones you're used to. You did a lot of them in geometry. Alright, so let's look at x squared plus 8x minus 9. Alright, so we need to find two numbers that multiply to negative 9 and add to 8. Now, many of you may have done it in a box or an X. You're welcome to use whatever method works for you. Alright, but eventually we need to get quick at these. Alright, because we're going to be doing a lot of them. So I need two numbers that multiply to negative 9 and add to 8. Well, I have 1 and 9, 3 and 3. Which one's going to get me to 8? 1 and 9. So there's 4 possibilities. Either your 1's negative. I'm sorry, let's go. You're both positive. Your 1's negative. Your 9's negative. Or you're both negative. Now they multiply to a negative 9, so that rules out these two. So which one's going to add to positive 8? Well, this is my culprit right here. So I have x minus 1, x minus 9. Again, I'm sorry, x plus 9. Again, this is our solution. If you wanted to check it, you could FOIL it back out. But all this work isn't necessary. If you can do it in your head, awesome. We will all get there. Now, the last one we have is, I'm sorry, it's not the last one. I have another one after this. X squared minus 2x minus 35. So I need two numbers that multiply to negative 35 and add to negative 2. So I have 1 and 35, 2 doesn't go in, 3 doesn't go in, 4 doesn't, 5 and 7, and I think that's it. 15 doesn't, nope. Alright, so which one's going to get me to 2? Well, 5 and 7, and 2 is negative, so the negative goes with the 7. Alright. Now, one more. Let's go 2x squared plus 26x plus 60. Alright, so here, before you go to factor, we're always going to look for a GCF first. Alright, so here you search for a GCF. If it's not a positive 1, we're always looking for a GCF first. Alright, so my GCF is 2. So I'm left with x squared plus 13x plus 30. Now, you always got to take a look at what's left inside your parentheses. Can this be factored any further? Two numbers that multiply to positive 30 and add to 13. So I have 1 and 30, 2 and 15, 3 and 10. And I think that's it now. I This one's a little tricky because both of these might work. However, it's positive. So what numbers are going to multiply to positive 30 and add to positive 13? Well, that's going to give me x plus 3, x plus 10. All right, now, so if I just say factor, that's what you would do there. What if I gave you one that said factor and solve? Now, how do we tell the difference? Well, in the factor and solve problems, I make it equal 0. That's it. All right, so factor it the exact same way. However, there's an extra step that's going to need to be done at the end. So search for GCF first if you don't have a positive 1. So in this case, it's 3. So I have x squared minus 6x plus 8 equals 0. So what's left inside, I need two numbers that multiply to negative 8 and add to negative 6. So I got x minus 4, x minus 2. Now when it's equal to 0, we want to find out what's going to make this whole thing equal 0. So ZPP, or zero product property, tells us to x minus 4 equals 0, or x minus 2 equals 0. So x is 4 and x is 2. All right. Again, what that indicates is what's going to make this term 0 so that the equation is true. What's going to make this term equal 0 so that equation is true is those two there. Now, the first problem we're going to start with tomorrow, I'm going to write in black off to the right here, 12x squared minus 25x minus 7. Now, if you notice, it does not have a lead coefficient of positive 1, and there is no GCF. So I'm going to leave you with that. Your homework assignment tonight is to bring this problem to class tomorrow and try to come up with the solution. If you think you know how to do it, impress me. If you don't, give it a whirl. But either way, I'll be checking. All right. Well, that's factoring in a nutshell, and we'll see you tomorrow to take it a step further. Thanks.